Good morning, guys. We are League of Legends Assistant Tool Team. This is our final presentation. Our presentation will cover following contents. Let my teammate start first.
Okay, here we come to the data collection part. Generally speaking, for the streaming function, we need three kinds of data. First, we collected the item build sequence of top 50 ranked players of the latest 30 matches. Together, we have more than 100,000 entries. This screenshot shows top 14 players of Champion Artox and the recent 7 matches of the first player. Second, we collected item build sequence based on different champions. We got the pick rate and win rate of each core build sequence and each item as well. This screenshot gives you the idea about how pick rate, win rate of each core build sequence and each items looks like of the champion Artox in top position. In order to implement object detection, we collected the base and variant profile picture of every champions. Here are the pictures we gathered about Champion Artox and Champion Ahri. We also collected the ruin data based on every possible ruin build sequence and the pick rate, win rate of each sequence. Inside the red rectangle is the one ruin build sequence of Champion Artox in top position. Inside the yellow circle is its pick rate and win rate.
For the model selection in our tool, we use CNN for image recognition and use linear regression for doing win rate prediction. This is the version number of the libraries we use for these models. This is the details of our training data for CNN models. Because champions' profiles are different in different stages, we need to train many kinds of image for all champions. We use more than 100,000 images for each kind of profiles as training data. In the right side is the example of different kinds of profiles shown in different parts or states of games. Similarly, we train item image with CNN for item build recommendation tools. This is the image examples. All of these image recognition have great performance with 100% accuracy rate. This is the accuracy learning curves and loose learning curves that change with the number of iterations. For the model of win rate prediction, we use linear regression to solve. We use items and their attributes as input to do fitting and predict win rates, and give recommendations of item build with largest expect win rate when facing different enemies with different items.
Okay, here is the first function, the Champion BAMPIC tool, and we collect 3 different types of champion profile images, use them as input for our convolutional neural network. After the image classification, we will have the champions' identities. Then we can use the name of those champions as input to find the champion who have the most similar win rate and basic stats to the champion banned by the enemy team. Then he will be a suitable alternative pick. For the second function, item build suggestion, we collect match history data and basic stats for items, convert the enemy team's item build into numerical data, and use these as input to train our linear regression model. And we use the same technique we used in function 1. And to detect the scoreboard, you can press tab to see the scoreboard in-game. And by detecting the scoreboard, we can recognize the items built by enemies and convert them into numerical data. Also, we collect all possible builds for the champion you are playing right now and use both them as input to predict the possible win rate. Then we will choose 3 items which has the highest predicted win rate, recommend them to our users. The last function is minimap warning. We use OpenCV to detect the red circles on minimaps, take screenshot of those circles, use CNN in function 1 to detect their identities. The output of this model will be a champion's name with his location. Then we evaluate their movement from level 1 to level 5. If we believe someone is approaching to you which means you are in danger, that will be a level 1 move, and we will send warnings on the top right of the screen.
When we decided to build an application containing those three functions, the first thing came into my mind was the MVC framework, because the MVC framework is a well-known software design pattern and is suitable to guide a team to develop a GUI project. Basically, the MVC framework divides program logic into three connected elements: model, view, and controller. The model represents the shape of data. It maintains the data application. The view is a user interface. The view is responsible to display data to our players and also enable players to modify the data by simply click a button. The controller handles the user requests and events, typically user index with view, which in turn write the appropriate URL request for some event. Those requests or events will be handled by several controllers, and then the controller render appropriate view as a response. So back to our application. Based on the same architecture, our model saves the game data, like your self-champion, enemy team's champion, and their gears and other supportive data. For example, the client heartbeat class keeps tracking the game client info every second, such as client size, client location on your screen. This information is pretty useful since we need to use the location to capture the image and use it to make a prediction. The only difference between our application and those normal GUI projects is we treat the TensorFlow model as a metadata as well, so that we can use a pre-trained model to do prediction tasks. The view layer in our application is built by PyQt5, which is a famous GUI library. There are two main parts in our view layer. One part is Paro, which reminds you that our application is running and enable shows the last message when you click it. The other part is notification panel. All the detection results and suggestions will be posted through this component. And some type notification panel will provide you automatic input function. Then we come to the controller part, which contains the most complex logic. Basically, all the detection and monitor work will happen here. We minimize user input and make it work automatically, because we hope our tool will help players focus on their game rather than spending time on clicking or doing some unrelated action. OCR decoder tells the application which status the client is, and the image processor captures a specific area of the screen and sends it to the deep learning model and get the result. Mouse keyboard listeners will monitor the player's action and give them the response. All the process managed by a multi-thread manager and keeps all the threads work properly. All the results generated by the controller will be sent to the view layer and pop up on your screen in appropriate time.
This is an overview of the whole structure. Yes, we do have some future steps. One thing is Ruinpig tool. We almost finished that. We finished data collection, backend design, but we facing a problem that we cannot detect my champion's identity, which we need to recommend the ruins. So we will keep working on that. Another thing is to keep our data up to date. This is very important because this game updates frequently. So we have to keep our data up to date as well. That is what we have to do in the future. Anyway, so far so good. Let's take a look at the demo first. Welcome to the demo for League of Legends Assistant tool. Now we've entered the Vanpeak session, the start of ranked games. Because we're recording in the customized game, each team has only 3 banks, but in the real rank they will have 5. Here comes the function 1, BP suggestion. A right pick is half to the win. We take screenshot of banned champions and detect their identities. Then calculate the most suitable pick based on their banks. When we finish the banks, the result will show on the right. The first 2 notifications show the result of champion detection. The last black one is now our pick suggestion. Click champion icons to pick. Simple and fast. Before we get into the game, we'll detect all enemy champions and double-check after the game starts. All in-game functions will not work if the double-check has a different result. Now let's speed up a little bit. Okay, here the game starts. Enemy champions, correct. What am I playing? No problem. It's time to see the power of this tool. Oh, minions coming! Don't miss any of them. Your major income in this game. You have the money, you can buy items. Items make champions stronger. Choose the right item to counter enemy's build, helps you win easily. Yes, use tab like that, you can check their builds anytime you want. Then hand it to us.
Tips: if you think this notification blocks your map, unchoose Display current builds in-game.
We detect their builds. When you go back to basement, we'll tell you what to buy to destroy them. Oh hey! Look at the minimap, bad boys coming! Yes, League of Legends is a team game. Sometimes your opponents will get help. To help you prepare for those ganks, we detect the minimap and send warnings. If someone keep moving towards you and then disappeared, fall back! As long as you prepared well, they won't have a chance. Hey, I'm talking to you, Annie. Come on. These bones just don't listen, right? Well, fortunately you do. Oh, look at the minimap. Someone start moving now. Moving to you. Warning! Warning! They comes again. We know you are coming, Camille. Fall back first. She's still chasing. Too deep, my friend. You die here. See? As long as you know they're coming, they're not problems. With the help of our tool, you don't have to take an eye on minimap. Just focus on the line and the operation. The game is that easy. Over $900. Yes, it's time to go home and shopping. And we promise to tell you what to buy. Here they are. Click and go. Okay, this is all we can do for you. You don't want to be reported as cheating, right? Huh? Good luck to all players. Stay safe in COVID-19. Thank you for watching our video. Bye bye.